Welcome to Mathematical Finance. Imagine you are traveling abroad and need foreign currency, but want to avoid hefty bank fees. What if you could just swap your cash with a friend and swap it back later? Today, we will explore how massive global companies do exactly this, and more importantly, how we calculate the exact mathematical value of these agreements. To begin, let us understand what a currency swap actually is. It is a financial contract where two parties exchange a principal amount and interest payments in one currency for those in another. Unlike standard interest rate swaps, the principal amounts are exchanged at both the very beginning and the very end. At the exact moment the contract is signed, the value of the swap is zero, meaning neither party has an immediate advantage. But as time passes, fluctuating interest and exchange rates cause the contract to gain value for one party and lose value for the other. Now that we know what a swap is, how do we value it? The most intuitive way is to treat the swap as a combination of two separate bonds. A bond is simply a formal IOU. If you are receiving foreign currency and paying domestic currency, you can imagine that you own a foreign bond and you owe a domestic bond. Therefore, the net value of the swap to you is simply the present value of the foreign bond you own minus the present value of the domestic bond you owe. We use continuous compounding to calculate these present values. Before we look at the math, let us visualize this exchange. Here we see the cash flow timeline for a standard currency swap. Notice what happens at time 0. The parties exchange the initial principal amounts. Throughout the life of the swap, they exchange periodic interest payments. Finally, at maturity, the original principal amounts are swapped back. The red arrows represent money you pay, which are your liabilities, and the green arrows represent money you receive, which are your assets. Valuing the swap means finding the net present value of all these arrows combined. This visual understanding leads us directly to our main valuation formula. V equals S0 times BF minus BD. Here, V is the total value of the swap expressed in your domestic currency. BF is the present value of the foreign bond, representing all the foreign cash flows you will receive. Because this is in a foreign currency, we must multiply it by S0, the current spot exchange rate, to convert it into our home currency. Finally, we subtract BD, the present value of the domestic bond, which represents the money you must pay. If the spot exchange rate increases, the foreign currency becomes more valuable, increasing your overall swap value. To use our main formula, we first need to calculate the present value of the domestic bond, BD. This formula adds up the present values of all future domestic payments. The symbol CD represents the regular interest payments, and PD is the final principal amount returned at maturity. We use the mathematical constant e raised to the power of negative RD times t to calculate continuous compounding. Here, RD is the domestic interest rate. By multiplying each future cash flow by this exponential discount factor, we shrink the future money down to its exact mathematical worth today. Similarly, we calculate the present value of the foreign bond, BF. The structure is identical to the domestic bond formula, but we use foreign cash flows and the foreign interest rate. CF is the foreign interest payment, PF is the foreign principal, and RF is the foreign interest rate. It is crucial to use the foreign interest rate to discount foreign cash flows. If the foreign interest rate increases, the discount factor becomes smaller, which actually decreases the present value of the foreign bond today. Now that we have our formulas, let us see this with a concrete example. A US company will receive 5 million British pounds and pay 8 million US dollars in exactly 1 year, with no intermediate interest payments. The US interest rate is 4%, the UK rate is 5%, and the spot rate is $1.50 per pound. First, we calculate the present value of the domestic bond, which is the $8 million we owe.
We multiply it by e to the power of negative 0.04 times 1. This tells us that paying $8 million in 1 year is financially equivalent to paying about $7.68 million right now.
Continuing with our example, we next set up the equation for the present value of the foreign bond. We take the 5 million British pounds we are going to receive and multiply it by its own continuous discounting factor. We use the UK interest rate of 5%, so our exponent is negative 0.05 times 1. Solving this exponential function gives us roughly 4.75 million British pounds. This tells us the exact worth of our future pound receipt in today's terms, before any currency conversion takes place. Finally, we plug our calculated bond values into the main currency swap valuation formula. We multiply the present value of the foreign bond by the spot exchange rate of 1.50 rupees. This crucial step converts the British pounds into US dollars, giving us about $7.13 million. We then subtract the present value of the domestic bond. The final result is negative $552,017.67. Because the number is negative, the swap is currently a liability for the US company. The dollars they must pay are worth more than the pounds they will receive. Let us look at a slightly more complex, real-world scenario involving ongoing interest payments. An institution has a swap with 1.5 years remaining. They receive 6% annual interest on 10 million euros and pay 5% on 12 million US dollars. Payments occur at 0.5 and 1.5 years. We start by calculating the foreign bond in euros. We discount the 600,000 euro interest payment over half a year and the massive 10.6 million euro final payment over 1.5 years using the 4% euro interest rate. Adding these gives a total present value of about 10.59 million euros. Moving on to the domestic side, we set up the present value calculation for the US dollar bond. The first term discounts the intermediate interest payment of $6 lakh over half a year. The second term discounts the final payment of $12.6 million over 1.5 years. Both terms use the US dollar risk-free interest rate of 3%. Calculating these exponential functions and adding them together gives us a total present value of 12.63 million US dollars. This represents the total current debt the institution expects to pay. Now we have everything we need to find the final net value of the contract. We multiply the total present value of the euro bond by the spot exchange rate of 1.15. This converts the entire stream of euro cash flows into their equivalent US dollar value, which is about $12.18 million. We then subtract the $12.63 million domestic bond. The final result is negative $4,55,757.81. Once again, this negative value means the swap is currently a financial loss and would be recorded as a liability. Having seen the calculations, you might wonder why this level of precision matters. Understanding how to value currency swaps is absolutely critical for the modern global economy. Multinational corporations constantly use these swaps to secure cheaper borrowing costs in foreign countries where they lack a strong credit history. Valuing these swaps accurately is essential for corporate accounting and daily risk management. If a company does not know the current value of its swaps, it cannot accurately report its financial health. Furthermore, if one party goes bankrupt, this exact valuation determines how much money is owed to settle the contract immediately, preventing a chain reaction of financial failures. Let us summarize what we have learned today. A currency swap is a powerful contract where parties exchange principal and interest in two different currencies. To value it, we simply compare the present value of the cash flows you will receive against the cash flows you will pay. By treating the swap as a combination of a foreign bond and a domestic bond, we can easily discount future payments to today's terms using continuous compounding.
Finally, we use the current spot exchange rate to convert everything into a single currency. You now have the mathematical tools to value any currency swap.